Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to go over your test number 3 solutions. Question 1, the D'Arsonval meter movement is one of the most common analog meter movements. That's true. Question 2, a voltmeter is placed in parallel with the device under test. That's true. Question 3, an ammeter shunt has a high resistance value. That's false. Remember, an ammeter shunt gets placed in parallel, because parallel and shunt mean the same thing. The ammeter shunt gets placed in parallel with the meter movement. It's going to have a very low resistance. Question 4, the ohm meter is designed to measure current. That's false. The ohm meter is designed to measure resistance. Question 5, the AC sine wave is so named because the voltage would be instantaneous voltage at any point along the waveform is equal to the peak voltage multiplied by the sine of rotation. That's true. Question 6, there are 250 degrees in one complete sine wave. That's false. One complete revolution is 360 degrees. Question 7, the inductive reactance and frequency are directly proportional. That's true. Remember the expression X sub L is equal to 2 pi times the frequency times the value of inductance. Question 8, the unit of inductance is the farad. That's false. The unit of inductance is the Henry. Question 9, impedance in an AC circuit is total opposition to current flow. That's true. Question 10, the maximum positive peak voltage of an AC sine wave occurs at 90 degrees. That's true. Question 11, the maximum negative peak voltage of an AC sine wave occurs at 180 degrees. That's false. The maximum negative value occurs at 270 degrees. Question 12, in a pure inductive circuit, the current lags the voltage by 90 degrees. That's true. Question 13, inductive reactance is measured in ohms. That's true. Question 14, wattage is a measure of true power. That's true. Question 15, the 120 volt branch circuit that supplies the receptacles in the front of our classroom is an RMS value. That's true. Question 16, a permanent magnet needs an external voltage to generate magnetic flux. That's false. Recall, a permanent magnet needs no external force or source for it to generate magnetism. Question 17. The x-axis on the oscilloscope measures time. Question 18. The y-axis on the oscilloscope measures voltage. Question 19. The term VAR stands for volt amperes reactive. Question 20, a non-clamping type AC ammeter is connected in series with the device under test. Question 21, the term RMS stands for root mean squared. Question 22, if the frequency of an AC sine wave is 60 hertz, calculate the time it takes to complete one cycle. So recall, time and frequency are inversely related. So time is equal to 1 divided by frequency. Frequency is equal to 1 divided by time. So to calculate the time it takes to complete one cycle, 1 divided by 60 is 0.0167 seconds, or 16.7 milliseconds. Question 23. If the peak voltage is equal to 150 volts of an AC sine wave, calculate the instantaneous voltage at 135 degrees. So the equation you're going to use, V instantaneous is going to be equal to V peak times the sine of theta, the sine of that angle. So if we plug the numbers in, V peak is 150 volts, and then we plug in the sine of 135 degrees, do the math, 106 volts would be the instantaneous value. Question 24. Calculate the inductive reactance of a 0.4 Henry inductor at 300 hertz. So X sub L is equal to 2 pi times F times L. Remember, 2 pi is a constant. Pi is 3.14, so 2 pi would be 3.14 multiplied by 2, or 6.28. Frequency is 300 hertz. Value of the inductance is 0.4 henries. Plug the numbers in, and we'll get a total inductive reactance of 754 ohms. And the last question, number 25, draw the symbol for an iron core inductor. So an iron core inductor, it's going to have the symbol of a coil with 2 horizontal bars above. Thank you.